Okay, boys, good morning once again, and welcome to the fourth day of myself doing this chapter 10, that is S block elements. Today is 20th of October, and I have one more class in the afternoon, from 12 o'clock to 12:40. Okay, now we were learning about the S block elements in previous class. We learned about the compounds of group 1 elements like sodium chloride, sodium hydroxide, sodium carbonate, sodium bicarbonate, sodium thiosulfate. Now today we'll be learning about the group 2 elements. Now before going to the group 2 elements over here, the thing which I have not completed is resemblance between beryllium and aluminum, a diagonal relationship. Now here, how are beryllium and aluminum similar to each other? Why are they similar? Because their ratio, the ratio of the ions, the charge by radius ratio, it is almost similar of these two ions, beryllium and what do you call aluminum ion. So that is the main reason we can say. Now here you can underline this sentence. The main cause of a diagonal relationship between beryllium and aluminum is that the charge by radius ratio of beryllium ion is nearly the same as that for the aluminum ion. Okay, so now the important points of resemblance between beryllium and aluminum are given over here point wise for comparative study. Number one, the electronegativity of beryllium, it is 1.57 on the Pauling scale. It is nearly the same as that of aluminum, 1.5. Number two, both beryllium and aluminum are resistant to the attack of acids. They are not attacked by acids easily. This is because of the formation of a protective oxide coating on the surface. Number three, both dissolve in alkalis to form soluble complexes like sodium berylate. Another one is sodium aluminate. These are all complexes with the liberation of hydrogen gas. Moving further to the next one, that is number four. Both the metals they have a strong tendency to form covalent compounds. Number five, the oxides of these metals are hard and they are high melting solids. Number six, the oxides and hydroxides of both beryllium and aluminum are amphoteric. So remember, these are amphoteric in nature. These are amphoteric in nature. That's why they react with both acids and bases to give salt and water. Number seven, the chloride of beryllium is predominantly covalent and has a bridged polymeric structure. In analogy to beryllium chloride, the chloride of aluminum is also covalent and exists as a bridged dimer. Okay. Number eight, carbides, compounds with carbon of beryllium and aluminum react with water to liberate hydrogen gas. But I request you to don't learn these equations. Okay. Now, after that, uses of alkaline earth metals. Metallic beryllium is used for making windows of X-ray tubes. It is used in the manufacture of several alloys also. Copper beryllium alloys are used in the preparation of high strength springs, vehicle springs and all. Magnesium is in the form of powder and ribbon is used in flash bulbs, flash powders, incendiary bombs and signalings. It forms alloys with aluminum, zinc, manganese and tin. Magnesium aluminum alloys are very light and tough and are extremely used for making aircrafts. An aqueous solution suspension of magnesium hydroxide called milk of magnesium is used as an antacid in medicines. Magnesium carbonate is widely used in making toothpastes. And after that, calcium is used as a reducing agent in the extraction of metals from their oxides. Calcium and barium metals are often used to remove air from vacuum tubes as they react with oxygen and nitrogen at high temperatures. The last one, that is radium salts, are used in the radiotherapy for the treatment of cancer. So these are the some of the common general uses of the alkaline earth metals which you should go through once. Okay. Now, after that, in your syllabus, there is some mention of some important compounds of magnesium and calcium which you'll have to learn. The first one, it is it is called magnesium chloride hexahydrate, and we need to go through and learn thoroughly its preparation from magnesium oxide and the effect of heat on this compound and the uses only. So this is there in your syllabus. So magnesium chloride hexahydrate. The formula is here. Okay, it is known as, it occurs as a mineral carnallite and also present in seawater. Now, preparation from magnesium oxide. The preparation from magnesium oxide is only there in the syllabus, so this is not required. Okay, only this one is required. Lab preparation in the laboratory. In the laboratory over here, it can be prepared by dissolving magnesium oxide. Okay, uh, or magnesium carbonate. So just follow this first equation only, not the second one. If you react magnesium oxide with hydrochloric acid, it forms magnesium chloride. Upon crystallization, the solution on concentration and cooling gives crystals of magnesium chloride hexahydrate. Okay, so this is required preparation only from magnesium oxide. Now, after that, effect of heat. Now, now we go to the properties. Now, under the properties over here, the second property we see, on heating, it undergoes partial hydrolysis to form a basic chloride, which on further heating decomposes to form magnesium oxide. So only the action of heat is required, which is there in the syllabus, not anything else. Okay. So if you heat magnesium chloride excited, it forms basic magnesium chloride, which upon further heating decomposes to give magnesium oxide. So you will learn these two equations. Okay. Nothing more than that. After that, coming to the uses now. The rest is not required. Uses are required over here. Now, uses of magnesium chloride hexahydrate. It is extremely used in the manufacture of calcium chloride or calcium carbide or bleaching powder. It is used in limelight, okay, for producing fluorescence, phosphorence, okay, illuminating purposes. It is used for drying gases and alcohol. It is used in the purification of sugar in the sugar industry. It is used as a building material and for whitewashing. It is used in paper and leather industries. In agriculture, it is used as a disinfectant and a germicide. So that is the first compound of group 2 element, that is, which is called magnesium chloride hexahydrate. The next compound which is there in a syllabus, it is what do you call, hydroxide and calcium oxide. So since the book contains calcium hydroxide, we will first what do you call over here go through what do you call, this was the uses of calcium oxide. We'll just come to what do you call this calcium oxide. The uses of calcium, what do you call, magnesium is over here. There are three uses. Okay, I just missed it over here. Calcium oxide. The next one is calcium oxide. We'll discuss its preparation from limestone and reaction with water, carbon dioxide, and silica. Only that much. Now, under calcium oxide, which is called quicklime, preparation only from limestone is required. Don't learn anything else, just the equation only. And after that, reaction with water, reaction of limestone with water. So you will skip the properties over here, just try to learn the reaction number 4, reaction of limestone with water. It reacts with water to form calcium hydroxide. Okay, then uses I already discussed over here. It was not for magnesium chloride hexahydrate. This is the uses for calcium oxide. Okay, now after that, the next one which is there in the syllabus, it is calcium hydroxide, which is also called snake line. Preparation of calcium hydroxide from calcium oxide. Only this, only the equation over here. Okay. It is prepared by treating lime water with what you call water, slaking of lime. This process is called slaking of lime. Now, after that, properties are not required. Only the uses. Only the uses of what you call this calcium hydroxide or slake lime. So, uses are there on the next page over here. Calcium hydroxide is used in the manufacture of bleaching powder, caustic soda, sodium carbonate. It is building material, softening of hard water. It is used as a lab reagent. Okay. Now, after that, the next compound which is there in the syllabus is calcium carbonate, CaCO3. Now, calcium carbonate, the preparation from calcium hydroxide and uses only is there. The preparation from calcium hydroxide, that is only this one is there. Now, here to prepare calcium carbonate in the laboratory, calcium carbonate, what do you call, precipitated chalk, can be prepared by passing carbon dioxide through lime water or adding sodium carbonate solution to calcium chloride. So there are two methods. This is one method, this is another method. So you just follow the first method only, by passing carbon dioxide gas through lime water. The second one is not mentioned in the syllabus, so no need to learn that. Okay. After that, the uses The uses of calcium carbonate. If you look at the uses of calcium carbonate on the next column over here, you will find that you will find that the first use the first use is limestone. It is used for the manufacture of lime cement, glass, and also washing soda. Washing soda, I have mentioned the formula in the previous classes. It is Na2CO3 dot 10H2O. It is also used in the extraction of several metals in chemistry, in the industry. Marble, that is calcium carbonate, is used as a building material for construction purposes. Now, precipitated chalk, that is calcium carbonate, is used in the manufacture of paints, distemper, whitewashing, cosmetic powders, medicines, and toothpaste. Okay, so these are the compounds of till calcium carbonate which is required to be learned from this chapter. After that, calcium sulfate. If you look at this calcium sulfate over here, this calcium sulfate dihydrate, this is also required. It is called gypsum. It is called what? Gypsum. Okay. And for this gypsum, we have to learn. This is called also plaster of Paris. It is called plaster of Paris. It is called plaster of Paris. Now, it is occurs in the nature in the form of anhydrite, calcium sulfate, and gypsum. Large deposits of gypsum are found in Punjab and Rajasthan. That's why we get to import what do you call all the marbles and what do you call the tiles for the flooring house for flooring building material. They are manufactured, all the factories, most of them you will find in Punjab, Rajasthan only. Okay, now this plaster of Paris, only the use what do you call preparation is required, preparation from gypsum. Now in the laboratory, in the laboratory, this compound over here can be prepared by treating calcium carbonate or calcium chloride. So we can obtain calcium sulfate. Okay, that is how we prepare this compound, that is calcium sulfate, which is called gypsum. Okay. Now after that, the properties are not mentioned over here, so you will learn only the uses of, that is what you call calcium sulfate dihydrate. The uses are given over here. It is used in the manufacture of plaster of Paris. It is used in the manufacture of cement and mortar. It is also used in the treatment of soil. Okay. Then, then after that, plaster of Paris is also required. Plaster of Paris and gypsum is separate. Okay. So here, plaster of Paris preparation from gypsum. So to prepare plaster of Paris, the preparation from gypsum, it is mentioned on page number 621. It is prepared by the partial dehydration of gypsum by heating it in a kiln, iron kiln, a hot furnace to this temperature with agitation, lot of agitation. So if you heat, what do you call this compound, calcium sulfate dihydrate at this temperature, it produces what do you call plaster of Paris. Okay, so only the preparation and the uses. Now, what are the uses of gypsum? Let us see. Uses you'll find over here. Here on the uses, plaster of Paris
তারা
is
প্রপোজ করতে হবে না
used for making molds for casting statues and all. It expands on setting and is very useful for this purpose. It is used for making statues, models, and other decorative items. It is used for making various patent plasters, and which is used in surgery for plastering fractured parts of the body. Suppose you have a arm fracture, then they use plaster of Paris for the setting of the bones naturally. It is largely used in the building, what do you call, industry. It is also used in making blackboard chalks also. So these are the various uses for what you call plaster of Paris. Now, after that, the next thing which is required is cement, manufacture of cement from this chapter. So under this cement, Article 10.7, this comes under industrial chemistry in higher chemistry. So here it has been put in this chapter because there is use of the group 2 elements. Now we know cement is one of the most important building materials. It is also known as Portland cement because on setting it becomes as hard as Portland rock, a famous building stone of England. So this is from what you call, this name is taken from a very hard building stone which is from England. The cement was discovered by a mason, Joseph Aspidin, in 1824. Now this mason is famous after the discovery, though he was not educated so much. Now, What is the composition of cement? So these are the things, different types of cement possess different chemical composition. The average composition of Portland cement is given below. Like calcium oxide is 50 to 60%, silicon dioxide is 20 to 25%, aluminum oxide is 5 to 10%, magnesium oxide is 2.5%, iron oxide is 2.5%. So if you mix all this in this particular percentage ratio, then we get to see what is called cement. Now, a change in the percentage of this constituent changes the quality of the cement. So if you want to maintain a good quality of cement, then you must maintain these percentages accurately. For example, a lower percentage of lime decreases its strength. So if the lime is less, the cement becomes of poor quality. Okay, whereas a higher percentage of it causes cement to crack after setting. So if you put again high percentage, more than 60%, the cement after you cast, after you do some dalai of your building, that time there will be cracks coming after. That's why it is very important to use good quality cement containing the required percentages of this composition. Okay, now after that, the manufacture is required. Now, under the manufacture of cement, here I will just explain you in detail. The main raw materials needed for the manufacture of cement are limestone and clay. Okay, I'm underlining it. Limestone provides lime, whereas clay provides silica. Alumina and iron oxide. Okay, gypsum is also needed at a later stage in its manufacture. The manufacture of cement is carried out in the following steps. First is mixing of raw materials. The raw materials like limestone and clay are mixed either by dry process or by wet process in the required percentage ratio. Then the dry process is like this. This process is used when the raw materials are hard and dry. The limestone is broken into small pieces, and mixed with clay in proper proportion. The mixture is powdered and pulverized to get a uniform mixture known as raw material. This is by dry process. Okay, mixture. Or if you apply wet process, it is slightly complicated. It is lengthy also. Here in the wet process, the process is used when the raw materials are soft and damp, containing moisture. Clay is washed with water and then mixed with crushed lime stone in proper proportion. The mixture is finely ground and homogenized. The product is known as slurry. After that, burning in rotary kiln. Burning where? In rotary kiln. Now, the raw materials from the dry process or the slurry from the wet process, from the dry process and the wet process, is charged from one end of a bin, yeah, what you call rotary kiln, oven sort of thing, which rotates on an axis. The rotary kiln consists of a long steel cylinder resting on rollers and made to revolve slowly. The kiln is heated by a blast of burning coal blown from the other side. Due to revolving of the kiln, the charge moves from one end to the other and gets heated to this high temperature. After which you can see the diagram over here. This part, no, it is this part is there. Okay, this is called rotary kiln. It rotates, and the reactions are important. Now the reactions for the manufacture of cement, they are pretty important, very very important. So I will request you to learn these equations properly. This much equations for doing the manufacture of cement, which is also called Portland cement. In the first step, you can see this is the given over there. Okay, calcium carbonate, it is heated, it forms calcium oxide. Then calcium oxide with silicon dioxide, it forms dicalcium silicate. After that, this it forms tricalcium silicate. Okay, then it forms tricalcium aluminate, and finally it, it is mixed with alumina and iron oxide to form this compound, which can be called as important constituent, which is called cement. Okay, now the resulting product is in the form of greenish black or grayish colored hard balls and is known as cement clinker, containing some impurities. It is taken to a revolving tube known as cooler where it gets cooled. After that, it has to be grinded properly. Grinding with gypsum. The cement clinker obtained from the rotary kiln is mixed with 2 to 3% of gypsum and ground to an exceedingly fine powder in grinding machines. Gypsum is added to regulate the setting time of the cement. Otherwise, if the gypsum is not added, what will happen? If we add water to cement, it does not contain gypsum, it will solidify very fast. So setting time becomes very, very fast. You don't want cement to set very fast. If the cement sets very fast, that means your building of the house will not become proper. Okay. Now, the fine powder thus obtained is Portland cement. It is packed in airtight bags and sold in the market. Okay, as cement, like there is Ambuja cement. Okay, there are so many other brands, L&T cement. Okay, so after that, setting of cement, when this cement is mixed with water, cement gets set to a very hard stone-like mass. It is believed that cement reacts with water to form a gelatinous mass. This undergoes dehydration and forms three-dimensional cross-linked links between silicon and silicon oxygen aluminum chain. This results in it setting into a very hard mass. That's how we make our buildings. Okay, so that is how you manufacture cement. Now, the concrete and reinforced concrete RCC, we call RCC. RCC wall is to be made whenever there is landslides, okay, to prevent the landslides from happening. So here, a mixture of cement, sand, gravel, and water is known as concrete. So remember this. It sets to a very hard mass and is generally used for construction purposes. If the cement concrete is filled in and around a wire setting or skeleton of iron rods and allowed to set, the resulting structure is known as RCC, reinforced concrete or RCC. RCC structures are very strong and are used for the construction work, roofs, bridges, beams, etc. Now, several other substances also possess properties similar to some like fly ash, Harani, Harani, fly ash, a waste product from the steel industry is one of them. This can be added to cement to reduce the cost without affecting the quality. That means rice husk is also added in the olden days, has also been used to prepare cement because it contains a high silica content. So, this was the manufacture of cement. Most importantly, don't just refer to the diagram, but don't learn the diagram. Most importantly, are these chemical equations during the manufacture of cement. Now, after that, we'll come down to the biological importance of magnesium and calcium from the group 2 elements. How are they important biologically? Let us see that. Okay. Now, magnesium and calcium play a very, very important role in biological systems. Now, an adult human body contains about 25 grams of magnesium and 1200 grams of calcium compared with about only 5% of 5 gram of iron and 0.06 gram of copper. Magnesium is an important constituent of chlorophyll, which is the green coloring matter present in plants and is responsible for initiating the process of photosynthesis, which I've learned in biology. The structure of chlorophyll is given over here. Okay, the structure of chlorophyll is given over here. You can have a look. In the center, there is magnesium metal. That is the only metal over there. Rest are non-metals. Now, if you look at point number B, magnesium ions also present in cellular fluids in animal bodies. In the fluids of animal body, they are more concentrated in intracellular fluids than in extracellular fluids. That means you'll find more magnesium ions in the inside the cells rather than outside the cells. All enzymes that utilize ATP in phosphate transfer require magnesium as cofactor. That is, cofactor means the presence of magnesium and is essential for activating phosphate transfer enzymes, which participate in the energy releasing biochemical process occurring in animal body. That means for the production of energy requirements to carry out the various physical activities by the body, we need some energy, and that energy is activated by this magnesium, which is acting as a cofactor. The number C, magnesium ions along with calcium ions transmit electrical impulses along the nerve fiber and helps in the contraction of muscles. Okay, so this is important. Magnesium along with calcium transmit electrical impulses, signals along the nerve fiber, and that's how it helps in the contraction of muscles, contraction and relaxation of muscles. Okay. Then we come to biological importance of calcium. Now, under this biological importance of calcium, just remember that calcium ions are present in phosphates in the human bones, animal bones of both human beings and animals. They are essential for the formation of bones and teeth. Now, remember, 99% of body calcium is present in bones and teeth. 99, only 1% you will find in the muscles or maybe in the what you call the fluid system of the human body. Calcium ions play an important role in the muscle contraction. Calcium ions are essential for maintaining rhythm of heart and for clotting of blood. The calcium concentration in plasma is regulated at about 100 milligrams per liter. It is maintained by two hormones, calcitonin and parathyroid hormone. Okay, so it has to be maintained. Otherwise, if there is excess calcium, also that is not a good sign. It is a disease. Okay, calcium along with magnesium ions catalyze the formation of pyrophosphate linkages, which control various biological systems. The hydrolysis of pyrophosphates to release energy is controlled by again calcium ions. So this brings us to the end of this chapter, that is S block elements. Now over here, this magnesium sulfate Epsom salt is not mentioned in the syllabus, so we'll not go through this. There are some other compounds, this is also not there in the syllabus. Now on page 630 of a textbook, please go through this objective multiple type questions compulsorily. Okay, the answers you'll find it there only after the questions. So try to tick the correct options, answers, okay, and prepare for your examination. The answers you'll find over here. Along with these MCQs, try to solve the true or false type questions. The answers of this also given over here. And most importantly, never leave out any fill in the blanks. Fill in the blanks also help you prepare a lot for the chapter. Okay. Now, since the chapter is complete, there is a lot of time left for me to lead the class. I will today now like to record the attendance, record your attendance, okay, manually. Okay, I'll record the attendance manually. Okay, so please hang on over there. So the first boy over here, roll number one, Aditya Chetri, absent. Then Abhinay Tamang, absent. Abhiyan Raj Rai, absent. Abhyas Rai, absent. Abhi Albon Yasan Guru, absent.
Present, sir.
Abhi
Present,
Albon
sir.
present.
Yes, sir.
Okay, good.
Yes, sir.
Then Achut Rai,
Present, sir.
present. Achut Rai is present.
Absent.
Achut Rai is absent. Okay, absent.
Present.
Present.
Yes, sir.
Okay, just I'll verify after some time. Aditya Ruchal, absent. Aditya Roshan, absent.
Present, sir.
Aditya Roshan is
Present,
present.
sir.
Huh?
Yes, sir.
Okay,
Yes, sir.
present. Then after that, Akash Pradhan, absent. Ankit Pradhan,
Yes, sir.
present. Then Aradhya Bhushan Devan,
Absent.
Present.
present. Please don't speak for somebody else. Okay, if your name is not called, do not speak. Ashwit Pradhan, absent. Vibhor Thapa, absent. Vyom Pradhan, absent. Kamila Singh, absent.
Present, sir.
Kamila Singh present? Okay, present.
Present, sir. Yes, sir.
Kamila Singh is present. Okay. Then Chrysanthus Dakim Lepcha,
Present, sir.
present. Daksha Kumai is not there. Digant Chetri,
Present, sir.
is present. Then Dipmal Thapa, absent. Dorji Wangchuk Gurung, absent. Emmanuel Panu Lepcha, also absent. He's gone to the school to submit the project. Torma Namgel Tamang, absent.
Present, sir.
Present. Then Kashyap Subba, absent. Chitish Gurung,
Present, sir.
present. Then we have Lesang Bhutia, absent. Nehal Shankar is also absent. Nawang Topdan Bhutia,
Present, sir.
present. Nishal Gurung, absent. Northern Lepcha, absent. Omrai, absent. Okay. Pranil Raj Pradhan,
Present, sir.
present. Then Pranav Khaling, absent. Rahul Prasad, absent. Rivas Gazmer, absent. Riyazat bin Rikesh Pokhrel, Rohan Kapil, present.
Present, sir.
Sabanian Jamling,
Present, sir.
Saksham Rai,
Present, sir.
Samin Ahmad, present.
Present, sir.
Shoyam Rai, TC. Sriraj Pradhan, absent. Siddharth Gurung, absent.
Present, sir.
Siddharth Gurung, present. Siddharth Gurung,
Yes, sir.
okay.
Yes, sir.
Siddhant Sharma,
Present, sir.
present. Sonam Chiring Bhutia, absent. Spandan Thapa, absent. Stanislas Lepcha, absent.
Present, sir.
Stanislas Lepcha, present. Stephen Gurung, absent. Sudhin Rai, absent. Sudhivya Tamang, absent.
Present, sir.
Sudhivya is present. Sujal Gurung, absent. Syed Saz Hassan, absent. Tashi Chedup Tamang, absent. Thupden Chering Lepcha,
Excuse me.
Present, sir.
Thupden Chering is present.
Present, sir.
Yeah.
So
Upal
she just
Munshi,
present.
what present? Who is
So
present?
she just present.
Sriraj Pradhan. Where were you when I called the name? Where were you?
So my network.
Network, okay. Upal Munshi,
Present, sir.
present. Upamanyu,
Present, sir.
Vidhan Dahal, no
Present,
electricity,
sir.
present.
Present, sir.
Vidhan electricity has come.
Yes, sir.
Okay. Vinayak Mani Pradhan, absent. Vansh Pradhan,
Present, sir.
Vansh Pradhan is present. Okay, so these were the boys who were present. Okay, I'll keep a
Sudhin
very.
Rai present.
Sudhin Rai. Okay, where were you, Sudhin,
Present,
my
sir.
dear? Where were you there? Where were you
So
when I was
that
taking
my
that
light.
light? Which torch
So my
light?
Wi-Fi was not there.
Oh my God.
So my light went.
Okay. So see, boys, those who are missing the classes this way, please try to watch the videos, because you might be thinking, taking it too lightly just now, the classes, but these, whatever deliberations I'm doing just now in the classes, these are going to help you in the examination. Please believe me, okay? Because there is no option for you not to believe, okay? Now, with this, I would like to end the class here only, okay? And now you can get ready for the next class. What do you have in the second period? Huh? What do you have in the
So
second period? Okay, good. Thank you so much. Have a nice day.